Okay. Now that we are done with the first part of our session, let us now proceed to the second part, which is discussion. Well, of course, after you conducted experiment, there should be a lecture or discussion. Okay. In this part of the lesson or of the session, I'm going to show you some calculations. Okay, so it's stoichiometry part of chemistry. Okay, so let's start. The first thing that we conducted is we created elephant's toothpaste. Experiment again, you have observed the decomposition of hydrogen peroxide. Okay, decomposition, as what I've mentioned earlier, it is the breaking down of a large or complex substance into two or more simpler substances. Okay, so in this case, we have hydrogen peroxide decomposes to water plus oxygen. So we have the hydrogen peroxide, and then we created water and oxygen. So in chemical formula, it is 2 moles of H2O2 or hydrogen peroxide producing H2O and oxygen. Now, some of you will ask, why do we have to put 2 in front? Why do we have to put 2 in front of H2O2 and 2 in front of H2O? And why is oxygen O2, not just O? Okay, so to answer that, the first thing is O2. Oxygen actually is a diatomic molecule. It exists here or in the environment or in the surroundings as O2 or diatomic molecule. Diatomic means 2 atoms in a molecule of oxygen. When you inhale like that, it's not just O, it is O2. It's a molecule of oxygen. And then you will ask me, why do we have to put 2 in front of H2O2 and 2 in front of H2O? Well, actually, that is to balance. That is to balance this equation. Okay. So here we have created an elephant's toothpaste. Okay. Now, here is the decomposition of hydrogen peroxide. You have 2H2O2 and then 2H2O and then 2O2. Now, teacher, why is it that you have here AQ? AQ means aqueous, means it contains water. So you will learn that also when you go higher. And then H2O, what does that L mean? That L means liquid. We know that water is a liquid, so you can put the L. If it's steam, then you have to put the G because steam is a gas, so you have to put the G. You will learn that also. Then oxygen, well, of course, it's basic for you and for all that oxygen is a gas, so that is O2G. That G means gas. Okay, so let's proceed. Let's continue. Now, the volume of H2O2 that we have used is 25 cm cube. Okay, by the way, class, in doing calculation in chemistry or in your curriculum, you should convert all the volume that you're going to use to dm cube. Dm cube or decimeters cube or liters or decimeters cube. And you know that 1 dm cube, okay, 1 dm cube is equal to 1000 cm cube. It is 1 dm cube is equal to 1000 cm cube. So to get the dm cube from cm cube, you just have to divide 25 to 1000. So 25 divided by 1000, you have 0.025 dm cube. Okay, so let's proceed. Next is the concentration of H2O2. So concentration of H2O2 that we used here is 11.5 moles per dm cube. The next, volume of gas produced. So that is the one that we are going to identify. Okay, so moles H2O2. So the first thing that you have to do is to identify the moles of H2O2. Next is the moles of O2 or the moles of oxygen, and then the volume of oxygen gas. Again, first thing, identify the moles of hydrogen peroxide or H2O2. After that, identify or calculate the moles O2, and then the last part, you can get now the volume of oxygen gas. Later, I'm going to show you a past year paper which asks the same question. Okay, IGCSE past year paper which asks the same question. So let's proceed. So moles H2O2, its concentration is equal to moles of H2O2. So this is the formula that we are going to use to identify the moles of H2O2. We know the concentration, which is 11.5, and then we know also the volume of H2O2 that we use, which is 0.025 dm cubed. So let's continue. Let's substitute the given. So concentration is 11.5, then the volume is 0.025. Okay, actually, you can have a direct formula for this one, but I want to start with this always. I always want to start with this one so that you don't have to remember so many formula. If it's concentration, moles, and volume, you just use this formula, and then you substitute the given, then you can get the answer. You don't have to memorize so many formula. So that will be 11.5 times 0.025 equals the moles of H2O2. Then, when you multiply that, you'll get 0.288, which is the moles of H2O2. Now, we have the moles of H2O2. Now, we're going to identify the moles of O2. Okay? So, how do we identify the moles of O2? For you to get the moles of O2, you will be needing mole ratio. Mole ratio means the ratio of the substances present in the reaction. So let's say, for example, the first one, the H2O2. How many moles are there here in the H2O2? So as much you can see, there are 2 moles of H2O2 here, then 2 moles of water, and then if nothing is indicated, it means it is 1. If nothing is indicated, it means it is 1. If nothing is indicated, it means it is 1. Remember that. Okay. So that is 2H2O2 will produce 1 mole of O2. So the ratio that we have here is that 2 moles H2O2, if we're going to use 2 moles of H2O2, we can produce 1 mole of O2. So that is the ratio we have in the balance equation. 2 moles H2O2 will produce 1 mole of O2. Okay. Now, to proceed with the calculation, you know already that there are 0.288 moles of H2O2. So 0.288 moles H2O2 multiply with the mole ratio. So here is the mole ratio. 1 mole O2 over 2 moles of H2O2. Why do we have to put H2O2 below? We have to put H2O2 below because we are looking for the moles of O2. We are looking for the moles of O2. Okay, so you can cancel moles H2O2, then moles H2O2. Actually, some of you, if you know how to do this already, you can easily know what are you going to do. If you know the ratio, you can actually identify the moles of the other substance given the mole ratio easily, if you know that already. But since this is the first time, I'm going to show you the step-by-step on how to do this. So that is the moles of H2O2 multiply with the mole ratio, which is 1 mole O2 and then 2 moles H2O2. Then when you compute this, this will be 0.228 or 288 multiplied by 1 divided by 2. So this is multiplied by 1 divided by 2, and when you proceed with the calculation, you'll get 0.144 moles O2. So we have now the moles of oxygen. The next one is the volume of oxygen gas. So how do we identify the volume of oxygen gas? Always remember this, class. At room temperature and pressure, 1 mole of gas is equal to 24 decimeters cubed of gas. It is at room temperature and pressure. Okay, sometimes you will see in the question, it is RTP. RTP means room temperature and pressure. Okay, in the exam, they will show you that RTP or at RTP, at room temperature and pressure. So in gas, in terms of gas, 1 mole of gas is equal to 24 decimeters cubed of gas. 1 mole of gas is equal to 24 decimeters cubed of gas. So if you have 2 moles of gas, so that will be multiplied by 2 and it will be 48 decimeters cubed of gas. Just simple as that. It is at room temperature and pressure. Now, to solve this one, so you have here volume is equal to the number of moles times 24. We are looking for the volume of oxygen. We are looking for the volume of oxygen. So that is volume equals to number of moles times 24. Okay, times 24. So we know the moles of oxygen, which is 0.144 moles O2, then multiply it with 24. So this will be like this. 0.144 times 24, then you will get the answer. It is 3.46 dm cube of oxygen gas. So in the experiment that we conducted, we have created 3.46 dm cube of oxygen gas. So now let's proceed to the past year paper. Well, actually, this question, or there's a kind of question which is the same as this one. Okay, so look at this one. This is chemistry paper 4 theory. So it's paper 4, so it's extended. February, March 2016, variant 42. So here is the question. Hydrogen peroxide or H2O2 decomposes into water and oxygen in the presence of a catalyst, manganese 4 oxide. If you remember, we used a different catalyst. The catalyst that we used is potassium iodide because that is the one available here on the lab. Okay, but actually manganese 4 oxide, potassium iodide, it will give you the same result. Okay, because it's just a catalyst, meaning it's just speeding up the chemical reaction. Okay. Now, what is meant by catalyst? Okay, so I have shown you this one earlier. A catalyst is a substance that speeds up chemical reaction without being used up. So it's making the chemical reaction faster, or it's making the rate of the reaction increases or increased then without being used up. So this is how you'll get the 2 marks because it is 2 marks. So 1 mark for substance that speeds up chemical reaction and then without being used up. So that is another mark. So that is 2 marks. Okay, then let's continue. So here is the graph. A student studies the rate of decomposition of hydrogen peroxide using the apparatus shown. The student uses 20 cm cube. So let's remember that 20 cm cube of 0.1 mole per dm cube of hydrogen peroxide and 1.0 gram of manganese 4 dioxide. Remember, class, that manganese 4 oxide is just a catalyst. It is just a catalyst. So never mind, you don't have to be concerned about the mass of the manganese oxide because it's just a catalyst. It will not participate in the chemical reaction. It's just making the reaction faster. Okay, so the student measures the volume of the oxygen given off at regular time intervals until the reaction stops. The graph of the result is shown. So here is the graph. Okay, so now let's proceed. So here are the questions. First, calculate the number of moles of hydrogen peroxide used in the experiment. So as what you can remember, this is just the same as this. You identify the moles. After you identify the moles of H2O2, you identify the moles of O2, and then you can get the volume of the gas. So let's continue. So in here, we know the volume of H2O2, which is 20 cm cube. So divide it with 1000, so that will be 0.02 dm cube or 0.02 decimeters cube. Okay, then concentration of H2O2, which is 0.1 mole per dm cube. And then we have to identify first the moles of H2O2. So same thing. Concentration is equal to moles of H2O2 over the volume. Concentration is 0.1 equals moles of H2O2 over 0.02. So concentration is here. Okay, here's the concentration, and here is the volume. Okay, so just like that, just substitute the given. Then after that, to cross multiply, that will be 0.1 times 0.02 equals moles of H2O2. So actually, you need knowledge in mathematics to answer this. Okay, to answer questions in stoichiometry. Okay, then that will be 0.002 equals to moles of H2O2. Now we have the moles of H2O2. Now that we know the moles of H2O2 we use, which is 0.002 moles of H2O2, we can identify the moles of O2 that we produce. So how are we going to do that? So of course, we're going to use the mole ratio. Mole ratio in this case, 2 moles of H2O2 is equal to 1 mole of O2. Meaning to say, you need 2 moles of H2O2 to produce 1 mole of O2. Now, how do I know it's 1 mole? Correct, because there is nothing indicated in front of O2. Okay? To solve this, we just have to multiply it with the mole ratio. So we have 0.002 moles of H2O2, then multiply with the mole ratio. Mole ratio is 1 mole of O2 over 2 moles of H2O2. Then when you multiply that, you will get the answer, which is 0.001 moles of O2. Okay, now we identified the moles of O2 already. Then we can proceed to the next question. Last question is calculate the volume at RTP. Again, RTP means room temperature and pressure. It is room temperature and pressure, okay, of oxygen produced. So we know that volume is equal to moles times 24. So volume is equal to 0.001 mole times 24. And when you multiply that, you'll get 0.024 decimeters cubed of oxygen. So in this experiment, we have created 0.024 decimeters cubed of oxygen. Okay. Any question in this? If you have any question, you message on the email or WhatsApp. See you again for the next science lessons. We are going to do more experiments for the next science lessons. Okay, bye-bye. Thank you, and go back to you, Mr. Romel and Ms. Tins. Bye.